Okay, so what are absolute and local max and mins? Absolute max and mins happen only on a closed interval, and it is whichever point is the highest and whichever point is the lowest, and value means output. That's a terrible T. Hold on. I don't know why it got misaligned. So output values are outputs. So absolute min happens there. What height is it? 0. And we'll note, just to make a note, at x equals 1. So absolute max is over here. That's the highest point on this interval. How high is that? 5. I think that's 7. Okay. Local max and mins. These are higher than their neighbors. Or for mins, lower than. So, for instance, this height is an absolute min because as a local min because it is lower than its immediate neighbors. So 0 at 1 is a min. So 0 at x equals 1. Another min is over here. What is that? Height 2 at x equals 4. And then a nice one over here is 1 at x equals 6. Okay. Notice they're lower than their immediate neighbors. Maxes, what height is that? 2 at x equals 0. That's 4. And what is that? 3 at x equals 5. Notice not so a local max or min has to be higher than surrounding points on both sides. So, okay, so how do we find local max mins using calculus? So local mins happen when the derivative is flat, 0, or when the derivative is undefined. Let me rewrite the word is. Seem to be unable to spell today. Okay, undefined. So they are places where you are, again, higher than your or lower than your neighbors. So just a little note. So just to be aware, they don't have to be the highest place. You can go higher eventually. So notice that first problem, we had several different heights that were local maxes and several different heights that were local mins. So how do you find absolute? Oh, one other thing is when you do this, the derivative can equal 0. We can just have a turnaround point where it stops for a second like a base camp, like x cubed, and then keeps going. So instead of calling them maxes and mins, we call them critical points or critical numbers instead. Critical point numbers if we're just considering the x values, and then critical points if we actually worry about the values, the outputs. Okay, so absolute maxes and mins, it's the absolute highest point must either be a local or relative or an endpoint. So in the problem at the very top, the absolute max happened at an endpoint and the absolute min happened at a local min. So what we do is, to figure out what's going on from calculus, we first find the critical numbers. So we plug in the critical numbers and we plug in the endpoints. You can do that the easy way by just tracing, of course. So we find the highest output that'll be the absolute max value. And just a note, along with absolute, some textbooks they're called global instead of absolute. So there's two different words that get used. Local and global, absolute and relative. Local and relative, absolute and global. So, yeah. Okay, how do you find the critical numbers? Again, f prime equals 0 or undefined. So we take f prime. And we'll note polynomials are never undefined, so we just look at f prime equals 0. Okay, factor out of 12 and an x. and then continue to factor the quadratic. Let's see, how does the quadratic factor? X and x, 2 and 1. We need a plus for the middle, so we need the bigger one to be plus. So x is 0, or x is -2, or x is 1. Here's a cute thing. Graph f, not f prime. You'll find that it goes off the bottom, so reset y min. Okay, how many of you are going to read that and write it down and then not actually do it? I'm going to guess 75% of you, you goobers. Try actually using your calculator. I'm so sure. Okay, critical numbers of this. Absolute value function is V-shaped. And it turns around at x equals 3. So if you take a look at the picture, it goes through 3, let's see, 7, and then goes down. So notice that we can't find f prime. Technically, they're rays, of course, but oh well. So notice the slope is 2 for x to the left of 3 and -2 to the right. You can't fix that, so we just say it's undefined slope and the middle. Okay, and notice that so it won't be an absolute max. If your interval only goes from like -1 to 2, then it would be an absolute max at 2. But sure, it is an absolute max even though the derivative is undefined. All right, 36. Find the maximum. Okay, so what do? We find f prime first. All right, this time the negative is in the middle, so it's x minus 2 and x plus 1. Graph the original function f and trace at all critical points and endpoints. So the critical numbers again were 2 and -1. The endpoints are, looks like, -2 and 4. So okay, so what's the absolute minimum? At a local max, a min, sorry. So that local min will turn out to be the global min for this interval, and the absolute max is, of those 4 numbers, is 33. Turns out to be at an endpoint. So it can happen either place. All right, oh look. The volume in cubic centimeters, oh look. Real world numbers. Aren't they icky? Okay, take the derivative. Good thing I did this in advance. So how do you find when this equals 0? Okay. Okay, so we're going to graph this and do calc zeros. This is V prime. Notice the interval is 0 to 30. So just so you can make sure you see it, we'll put x min and x max a little outside that interval. We also need to see small numbers. Okay, fine. V prime equals 0 only once on this interval. It is a quadratic, so it'll hit 0 again, but not between 0 and 30 degrees Celsius. Now, incidentally, we're going to graph using x, not t, right? Calculator's stupid, it can't deal with t. So, Oh, I forget what that temperature is in Fahrenheit, but it's in the 30s. Let's see. I'll do it on the calculator. 4 times 9/5, and then add 32. Calculator says, oh yeah, 39.2 degrees Fahrenheit. So this is why ice floats in cold water. Most solids don't do this. Water is fairly unusual in that it's densest as a liquid and gets less dense when it solidifies. Most solid versions are somewhat more dense than their liquid cousins. So, interesting little factoid.